Hi everybody, welcome to week 2 of our online learning. This video is going to walk you through section 4.3 out of unit 4, and it's going to review all the components of slope-intercept form. So, as a quick and friendly reminder, slope-intercept form, this is probably the most common type of equation that you see when it relates to graphing, because it has two very convenient pieces. It has the slope and the y-intercept. You'll notice here the form y equals mx plus b. M represents the slope, B represents the y-intercept, as you may recall. So, before we review the graphing part, let's just review how we can identify the slope and the y-intercept given the equation. So the first couple of examples are already in slope-intercept form. So, if I look at number 1 here, y equals x plus 3. This is in slope-intercept form. So all I have to do is rip off the slope, which is directly attached to the x. There's an invisible 1 there, so my slope is 1. My intercept is always whatever's being added or subtracted to the x term. In this case, the y-intercept would be 3. So my slope is 1, my y-intercept is 3. Second problem set up the same way. Y equals 2x plus 5. My slope is 2, my y-intercept is 5. Now, we can identify slope and y-intercept out of an equation even if it's not written in y equals mx plus b form, because as you probably remember, we can rewrite equations so that they are in y equals mx plus b format. So numbers 3 and 4 written in standard form. We're going to rewrite them set the y's by itself. So before we identify slope and y-intercept, we have to get y by itself. So I'm going to subtract away the x here in number 3. And then divide away, since it's negative y, we're going to divide everything by negative 1 to flip all the signs. So we'll get y equals x minus 1. Now we can identify the slope, which is 1, and the y-intercept, which is negative 1. Same thing in number 4. We've got standard form. We're going to get the y by itself by subtracting 3x. So we'll get 6y equals negative 3x plus 60. Divide everything by 6, we'll get y equals negative 1/2 x plus 10. Slope in this case would be negative 1/2, and the intercept would be 10. Problem underneath is the exact same thing, except it's just a multiple choice problem. So again, to identify the slope and y-intercept, we're going to get the y by itself. So we'd subtract 17x. So I'm going to show my work down here. Subtract 17x. So I'd have 4y equals negative 17x plus 68. Divide everything by 4. Y would equal negative 17 over 4x plus 17. So my slope would be negative 17/4, so my y-intercept 17. So D is the appropriate answer there. So this is just to briefly remind you how to identify those two main pieces, because when it comes to graphing, you're going to need those two things. So let's take a look here and review how we can graph. So, to graph a line using slope-intercept form, 3 key things. Get the y by itself, plot the y-intercept. From the y-intercept, use your slope to make more points using rise over run. Try to fill the grid with as many points as you can. So, number 6, we see the y's by itself. Great. We can identify the 2 main pieces that we need. We've got a slope of negative 4 and an intercept of 2. We start from the y-intercept, so since the intercept is 2, we go up 2 on the y-axis. With a slope of negative 4, remember, we want to use it in terms of rise over run. So if it helps visually, make it as a fraction of negative 4 over 1. Slope of negative 4 means we go down 4 and to the right 1. And I'll do it again since I have the space. And that'll get me enough points to make a nice straight line. If I wasn't able to go down and right, which I would say is quote-unquote the normal way, you can go up and left. That'll also show a negative slope. So I can go up 4 and to the left 1. Notice how it still makes a straight line. So I have all these different points. I can easily connect them here with a nice straight line. And there I have my graph. 7 is the exact same idea. The y's already by itself, so I'm just going to quickly identify my 2 main pieces. Slope of 3/4, y-intercept of 8. So I'm going to go up to 8 on the y-axis to start. Now this is where it's helpful to realize that you can go backwards with your slope. If I try to go up 3 over 4, there's not enough space to do that. I'd end up off the grid. So I'm going to go backwards. Instead of going up and right, I'm going to go down 3 and left 4. And I'm going to do that here a couple of times. And I've got myself the graph of my line. So pretty quick and easy to graph. You just need to make sure you identify the right two pieces. You do things in the correct order. And it should be pretty easy to figure out which way your lines should go. Now, when you look at a couple of examples here where they're not in your typical formatting here, so like an 8, we see it's not in not in slope-intercept form. It's currently in standard form where x and y are on the same side. So before I try to graph it, I'm going to add the x term, move it to the other side. So I'll get y equals positive 1/2 x plus 1. Now that the y is by itself, now I can identify my two main pieces, my slope of 1/2, my y-intercept of 1. I'll start at 1 on the y-axis, go up 1 to the right 2. And I can do that a whole bunch of times here. Or I could go down 1 and left 2 and still get the same slope. And there's my line. Now 9 has the y by itself, but you don't see anything being added or subtracted. It just says y equals 2x. Well, your slope is still 2, because that's the value directly attached to the x. Since there's nothing being added or subtracted to it, that means the intercept is at 0. Okay, 2x is the same thing as saying 2x plus 0. So I'm going to start from the origin and have a slope of 2 over 1. So I'll go up 2, right 1 a bunch of times. Or I'll go down 2 and left 1 a bunch of times. And there's my line. So that is a little quirk in terms of slope-intercept form. If you don't see anything being added or subtracted, the intercept is going to be 0, because plus 0 would allow you not to write that. Alright, finish it up here with a couple more examples of things in standard form. Again, it's all the same idea as you've seen, and something that you've definitely gone through many times throughout this year, whether in this class or in another math class. But if you want to see a couple more examples here, feel free to watch these examples. So I'm going to subtract 2x here in number 10, and then divide everything by 3. So in slope-intercept form, this equation would be y equals negative 2/3 x plus 4. So I have a slope of negative 2/3, an intercept of 4. So I'll start at 4, down 2 to the right 3, or up 2 to the left 3, and I have my line. And last but not least, 5x minus y equals 8. Same deal. Got to get the y by itself, so we're going to subtract 5x. Move that over. And then again, it's negative y, so you want to divide away the negative by dividing by a negative 1. That'll flip all your signs and leave you with y equals 5x minus 8. Slope of 5 over 1. Intercept of negative 8. So I start down here at the bottom of my graph. I go up 5 over 1, and I can repeat that here a handful of times and get my line. So that's your review on slope-intercept form, how to identify the slope, identify the y-intercept, whether it's written in y equals mx plus b form or written in standard form, and there's your steps there on how to graph it. So if you have any questions on any of that, feel free to go back and watch the examples again, or send me a message here and we can certainly help you out. Your assignment that goes with this on IXL is level K. We're going to remain in that still for the rest of the unit. Topic S19, it's the only one you have to do for this. Target score, as always, is to get it to an 80 for full credit. Make sure that you finish this by the deadline that I've set on the calendar posted on Schoology. And again, if you need anything from me, please don't hesitate. Send me a message, send me an email, and I'll be happy to help you out. Thanks for watching, and we'll see you next time.